We move on to another interesting topic, the human metabolism. Here we think of the human system as a thermodynamic system. Like any thermodynamic system, the relationship between delta U, Q, and W is governed by the first law of thermodynamics. But because of the diversity of the processes for humans, it is more convenient to deal with the time rate of change for these processes. So you divide by delta T. So here, the change of the internal energy per second is equal to the change in the heat energy per second plus the change in the work per second. Usually, the energy Q flows out of the human body and work is done by the human body on its surrounding. So both Q over T and W over T are negative. Naturally, for this to happen, to balance the equation, you need a source of energy. The source of the energy, of course, is food, oxidation. You have oxygen, you have food. This will provide the needed change in the internal energy such that the equation is balanced. This leads us to talk a little bit about the metabolic rate, which is proportional directly to the rate of oxygen consumption by volume. We may write the metabolic rate, delta U by delta T, in terms of the oxygen consumption here, using this formula, 4.8. This is proportionality constant, delta V, oxygen 2, divided by delta T. Some examples for the metabolic rate activity, the weight loss or weight gain. If you are doing light activities, walking slowly, square, dressing, then the oxygen consumption is 10 milliliter per minute per kilogram of your mass. The metabolic rate is 200 kilocalorie per hour. It can be expressed in watts to be 230 watts. On the other hand, if you take an extreme activity like bicycle racing, so the oxygen consumption is 70 milliliter per minute per kilogram of your mass. So rather than 10 for light activity, now it is 7 times greater. Okay. Moderate activity, you are talking 20 milliliter per minute per kilogram. This is a very interesting subject. Usually food scientists have many details here to discuss. Some examples: 1 pound of fat is equivalent to 4,100 kilocalorie. If you run 1 mile per day for 35 days, this will burn 4,200 kilocalorie. If you eat 2 fewer slices of bread per day, then 35 days per 2 slices per day per 60 calorie for each slice, kilocalorie. This is equivalent to 4,200 kilocalorie. So using these kind of formulas, we should be able to plan weight gain or weight loss strategy. If we are interested, we need to weigh the oxygen consumption for various activities, okay, and the energy content here, the energy spent for various activities, and from there one can go. These numbers are for a 65 kilogram meal. If the mass is greater or less, these numbers will change, of course. In this table, we have the physical fitness and maximum oxygen consumption rate, just to give you an idea. For an excellent fitness level, the oxygen consumption would be 70 milliliter per minute per kilogram. While for very poor fitness level, you are talking 28 milliliter per minute kilogram. So to improve your fitness level, you need to improve the oxygen consumption here. Okay? As simple as that. The efficiency of the human body can be calculated from the work per second divided by the change in the internal energy per second. This is some numbers for the efficiency for different activities. Like cycling, the efficiency can be 19%. Shoveling, on the other hand, is 3%, the least efficient. Why? Because in shoveling, it involves many starts and stops. Okay? It is very hard work. So the power output is 17.5 watts, while the metabolic rate is 570. Because of that, the efficiency is that low. We are done with this chapter. We learned about the thermodynamic systems. We learned about thermodynamic processes. We learned how to calculate the work from the change in the volume. The product P delta V will allow us to calculate the work. The work can be negative or positive. So if the displacement and the force are along the same direction, the work will be positive. If the displacement is in one direction and the force in the other direction, then work will be negative. Like here, the work done by the surrounding on the gas is positive, but the work done by the gas on the piston will be negative. The first law of thermodynamics is about conservation of energy. It tells us that the change in the internal energy for the system is equal to the heat energy that the system takes from the surrounding plus the work. Okay? So both these can be negative or positive. If the system takes energy, Q is positive. If the system releases energy, Q is negative. Okay? The internal energy means the energy of the molecules, of the atoms in the gas. So the hotter the system, the greater the change in the temperature, the greater will be the change in the internal energy. We learned about the four thermal processes in gases: isobaric, adiabatic, isovolumetric, and isothermal. We also learned about heat engines, which involves the heat engine and the heat pump. We learned that in any heat engine, there will be some part of the energy lost to the environment, to the surrounding, and because of that, the efficiency will always be smaller than 1. For the refrigerator, which is a heat pump, we need work from an external source to take energy from the cold reservoir and dump it at the hot reservoir. This does not happen spontaneously, does not happen by itself. In order for this to happen, we need to do work from an external source. Then we learned about the cyclic process and the Carnot cycle. We learned that Carnot cycle is an ideal reversible cycle. It sets the upper limit for the efficiency, and still this upper limit is always much less than 1. The last thing here we discussed was the entropy. It is defined as delta S equal Q divided by T.